Let's go to the test paper.
We're on test paper 2, part 4, question 9.
All right, great. So test paper 2, part 4, and question number 9. Is it this one?
Yes.
Great. So which question we have to discuss? Question number 9?
Yes.
All right. So can you read the question quickly?
A worker uses a forklift to move boxes that weigh either 40 pounds or 65 pounds each. Let X be the number of 40-pound boxes and Y be the number of 65-pound boxes.
Okay.
The forklift?
Stop here because as I told you that we have, whenever we're having verbal sentence, a big sentence, we'll be breaking that up into small portions, and then we'll be getting the information from each portion, and then we'll be trying to get the answer from the things which you have already calculated. So what you have understood till now?
So the forklift is moving boxes, and they're either 40 pounds or 65 pounds. And they saying that X are the number of 40-pound boxes and Y is the number of 65-pound boxes.
So what will be
X are the number of 40-pound boxes and Y is the number of 65-pound boxes.
So what will be the total weight of 40-pound boxes, which are X? Like what will be the, if for example, you're having two 40-pound boxes, what will be the weight of them in total?
80.
80, correct. When you're having three 40-pound boxes?
120.
Correct. So what you're doing is you're just multiplying 2 with 40 and then 3 with 40. For example, if you're having X 40-pound boxes, so what will be the total weight?
40X.
Correct. So 40X is the total weight of the 40-pound boxes. So let's write 40X. And what about 65-pound boxes?
65-pound boxes are Y.
So what will be the total weight of 65-pound boxes?
65Y.
65Y. So can we say that 40X plus 65Y is the total weight of X 40-pound boxes and Y 65-pound boxes?
Yes.
Okay. Now, can we read the next few lines?
The forklift can carry up to either 45 boxes or a weight of 2,400 pounds. Which of the following systems and of inequalities represents this relationship?
What's X?
X is the number of 40-pound boxes.
What's Y?
Is the number of 65-pound boxes.
So what should be the total for X and Y?
Less than or equal to 2,400.
Think about it again. I'm just talking about the number, not about the weight. Number of 40-pound boxes and number of 65-pound boxes. A forklift can carry up to either 45, exactly. So can't we say that X plus Y can be less than or equal to 45?
Yes.
And what about the total weight?
It has to be less than or equal to 2,400.
So what inequality should I write there?
40X plus 65Y is less than or equal to 2,400.
Good. Correct. You're done. Which option?
A.
Right. That's it. So whenever you're having big sentences, break them and analyze the the information which is given, get some insights from that information and use that for calculating what is needed in the question.
Okay.
Any confusion here?
No.
All right, so what's the next one?
Um, right. Um, 15. Is it 15?
Mm-hmm.
I think it might be 15. Yeah.
Mm-hmm. Okay, so and you have to check out all those questions, also, which may be right, but you need some explanation, which are not clear.
Mm-hmm.
Okay, let's go to 15. Can you read it first and make me
The
understand?
distance the distance traveled by Earth in one orbit around the sun is about 580 million miles. Earth makes one complete orbit around the sun in 1 year. Of the following, which is the closest to the average speed of Earth in miles per hour as it orbits the sun?
Miles per hour. So the speed is to be calculated, and speed is distance traveled divided by time taken. So always you'll be remembering this equation. Speed is equal to distance traveled divided by the time taken. So, well, we know that the distance is 580 miles, and we know that the time taken is 1 year. But don't we have to convert that into hours?
Yes.
So let's understand how many hours are there in 1 year. So how can you write that?
You can write
1 day, right? Starting from 1 day.
1 day equals 24 hours,
And how many days are there in a year?
365.
So don't you multiply 365 with this?
Mm-hmm.
Can you use the calculator and check it out? How much is it?
8,760.
So we'll be writing the distance is 580,000,000 divided by 8,700
60.
so you're done. Just calculate it on the calculator.
Mm-hmm.
Distance traveled divided by time taken. So distance is 580 miles, 580 million miles divided by time taken is 8,760 hours. And the
Mm-hmm.
answer we'll be getting in miles per hour. How much is it?
66,210.
And the question is telling you which of the following is closest.
Mm-hmm.
Which one is
A.
closest? That's right. So converting the dimensions. So that also needs to be, you have to be a little cautious here in these types of questions where one dimension is given and the answer is given in another dimension. So there's a need for conversion. Sometimes you're having liters, sometimes milliliters, sometimes kilometers, sometimes miles. So it all depends on what you have to convert from what to what. So that you can get the correct answer. And this formula you have to remember. Speed is distance over time, distance divided by time taken.
Okay.
Next one.
Is it 21?
21. Okay. All right, so let's try to understand this thing also and then analyze how to do this. So can you read it in parts and tell me the information from that?
Mm-hmm. A project manager estimates that a project will take X hours to complete, where X is greater than 100. The goal is for the estimate to be within 10 hours of the time it will actually take to complete the project.
What does that
If,
mean?
It's saying that the estimate time was 10 hours that will take to complete it. And it's saying that the manager estimates the project will take greater than 100 hours.
Can you think about it again? Like, first few lines. A project manager is estimating that a project will take X hours to complete. Okay, so we need a total of X hours, and X is greater than 100. So we need a total of like maybe greater than 100 hours for completion of the project. But the goal is, okay, it is taking X is greater than 100. It's taking like greater than 100 hours. But the goal is for the estimate to be within 10 hours of the time it will actually take to complete the project. So doesn't that mean that we have to be in 10 hours time? Like it should be either 10 hours less or 10 hours more.
Yeah.
From the goal, like from the estimate. The goal is for the estimate to be within 10 hours of time it will actually take to complete the project. So can't we say that it should be like, like from 90 to 110? Just think about it, if it is making sense.
Wait, why does it have to be like 110?
10 hours, it should be 10 hours within the estimate. The goal is for the estimate to be within 10 hours of the time it will actually take to complete the project. So if it actually takes to to complete the project is 100 hours, it should be within the 10 hours. Like it should not be going beyond 10 hours. You understand? It should not be going beyond 10. It should not be going like 120, 130, 140, and so on. It should be within 10 hours. So it should be up to 110.
Okay.
So that's what they're trying to give here, the information. And then they're telling you that if the manager meets the goal and it takes Y hours to complete the project. So doesn't that mean Y has to be in between 90 to 100? Oh, sorry, 90 to 110. Because it has to be within the 10 hours of the budget of the calculations. So if it takes Y hours to complete the project, which of the following inequalities represents the relationship between the estimated time and the actual completion time? Okay, so we are having a target of X hours to complete the project, and it's actually taking Y hours to complete the project. Now think about it. We're having a target of completing the project, for example, for 100 hours. And I'm completing the project in 105 hours. So what was the difference between the actual and the estimation?
5.
5. So it'll be like 105 minus 100. That'll be 5. In the same way, if I'm having, the estimation is X hours, and I have actually completed the project in Y hours. So what will be the difference between them? As you did, 105 minus 100. In the same way, we'll be doing Y minus X. Think about it. Okay, doing it again. If my estimation is to complete the project in 1,000 hours, okay? And I'm completing the project in 1,100 hours. Okay? And I'm completing the project in 1,100 hours. So what's the difference between like the estimation and the actual?
100.
100. So what you're doing is the actual minus the estimation, right? The actual minus the estimation. In the same way, if the actual is X hours and the estimation is Y hours, what will be the difference?
Y minus X.
Exactly, y minus x. And
Oh,
don't you have that in the range of like 10 hours? Like it should not be going beyond 10 hours, you understand? Like here,
mhm.
the goal is for the estimate to be within 10 hours of the time it'll actually take to complete the project. So y minus x has to be in between 10 hours time. It should not be going beyond 10 hours.
Okay.
That's what it is. So we are done actually.
So it's D.
So it's D, right? But at the same time, what we can do here, we can plug in the numbers to make it easier. For example, if x is greater than 100 and you have taken maybe 102 hours or 105 hours to complete the project. So if x is greater than 100, you can take whatever the number is, and y is let's take it as 107 hours. And let's take for x some number. X is maybe 102 because it's greater than 100. So the different so let's plug in x is 102 and y is 107 and check out which inequality makes sense. So you're getting here 102 plus 107 is less than 10. Totally not logical,
Mm-hmm.
What about y? Y is 107 is greater than 102 plus 10. Is that true?
No.
So not B. What about C? 107 is less than 102 minus 10.
No.
What about D? Negative 10 is less than 107 minus 102. That's 5. That's less than 10. Is that true?
Yes.
So this only makes sense.
Okay.
So that's also, that also can be done by plugging in the numbers. Or else what you can do here, you can actually think about like what could be the inequality. So x is greater than 100, y is the actual completion time. So their difference has to be within the 10 hours. So y minus x can be within 10 hours. It should be, 10 is less than y minus x is less than 10. Sorry, negative 10 is less than y minus x is less than 10. That means, y minus x is within the 10 hours time.
Okay.
Are you getting the, like,
Yes.
all right, so let's go to the next one.
Um, 22.
22. Can you read the information which is on the top of it?
I is equal to P over 4 pi R squared.
Mm-hmm.
At a large distance R from a radio antenna, the intensity of the radio signal I is related to the power of the signal P by the formula.
So they're giving you a relationship between the I, which is the intensity, and the P, which is the power, and the R, which is the distance from the radio antenna. So if you're having a radio antenna like this, and if you add a distance of like R, so this person is here at a distance of R. So the power of this is, let's take it as P, and the intensity of the radio signal is I. So they're giving you a relationship that if you're having, the intensive radio signal with some power with a distance of R, this person will have, I as the intensity. If the person is closer, obviously the intensity will be more. If the person is far, the intensity will be less, and so on, right? So it all depends on like where the person is. So if a person is closer, the intensity of the signal will be more. And it's obvious for even the mobile phones. If you're more closer to towers, then you're having, more stronger signal, even for the internet and everything. And if you're far, then the signal will be, not having that intensity. So that's the thing which they have given. I is P over 4 pi r square. And now the question 22 is telling you which of the following expresses the square of the distance from the radio antenna in terms of the intensity of the radio signal and the power of the signal. They are just telling you solve for r square from this equation.
Okay.
So in order to solve for r square, what should I do to both sides?
Divide by r squared.
It's already in division.
Oh, multiply.
So if you multiply by r square, I'll be getting I times r square equals b over 4 pi, because r square and r square will cancel out, right?
Yes.
And after that, I just want r square. What should I do to both sides?
Um, divide by I.
Exactly, divide by I. I and I will cancel out. R square is b divided by 4 pi I. You're done.
Oh,
Which option?
B.
Correct. So that's it.
Okay.
23 also.
Yes.
So we're having, here for the same signal emitted by the radio antenna, observer A. So if you're having a radio antenna, observer A is here. And let's take observer B here. Observer A measures its intensity to be 16 times the intensity measured by observer B. That means if observer B is measuring the intensity as I, the observer A is getting the intensity as 16 times I, correct?
Yes.
The distance of the observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? So we have to calculate the ratio or the fraction of the distances. So if you're having the distance of observer B as R, then distance of radio A, we don't know. Let's take it as, if this is RB, let's take it as RA.
Mm-hmm.
So that's what they're telling you, that what is the fraction of the distance of observer, like observer A to the observer B. So that's what we need to calculate. And we already have calculated that R square is P divided by 4 pi I, correct?
Yes.
So can we use it for the observer A? RA square is equal to P divided by 4 pi. What is I for A?
16.
Good. Yeah, 16I.
16.
And for RB square, we're having P divided by 4 pi I.
Yeah.
Yes, because we're having I for the observer B and 16I for the observer A. So we have to calculate the ratio. Can we divide the two then? If you have to calculate the ratio, because they're telling you the distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna. So we have to calculate RA divided by RB. So should we divide them? That's what they are telling us. The distance of the observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna. So RA squared divided by RB squared will be equal to B divided by 4 pi times 16I. That whole thing divided by P divided by 4 pi I.
Okay.
So P and P will cancel out, 4 pi and 4 pi will cancel out. And you're having I in the bottom, that will be jumping to the numerator, because if you're having A over B divided by C over D, that is equivalent as A over B multiplied by D over C always.
Okay.
So what I can write here, I can write RA squared divided by RB squared equals, I can write this, I will not be canceling it, I'll be writing it again so that you'll be having more clearance here. P divided by 4 pi times 16I multiplied by whatever the fraction you're having in the denominator, that can be multiplied by the, by making it reciprocal. 4 pi I divided by p. So whenever you divide by the fraction, whenever you divide by any fraction, it is equivalent to multiplying by its reciprocal.
Okay.
So now I can simplify this. I can have p and p cancels out. I can have 4 pi and 4 pi cancel out. I can have I and I cancel out. I'm getting 1/16. Check it out.
Okay, yeah.
So if RA square over RB square, can I write this as RA over RB whole square
Yes.
equals 1/16?
Yes.
Now what to do? Both sides to get RA over RB only, not the square thing.
Square root it.
Square rooted, good. So RA over RB equals,
1/4.
you're right, you're done.
Okay.
So option,
A.
correct. You can even use this equation. It's not necessary that you'll be using option B's equation. You can use this equation also, and then divide the two fractions. Still, you'll be
Okay.
getting the same thing.
Okay.
For I equals P divided by 4 pi RA square, and 16I equals P divided by 4 pi RB square. And then you can divide the two, and you'll be still getting somewhere RA square over RB square.
Okay.
So that way also you can do that. This is 23. Next one.
25.
Okay, 25. 24 is clear.
Yes.
Can you read 25?
The graph of the linear function f has intercepts at a0 and 0b
What does that
in
mean?
the xy plane.
A0 and 0b. So what is this actually? Where the y value is 0, isn't that x-intercept?
Yes.
Where the line cuts the x-axis. And if the x value is 0, what'll be this?
B.
It'll be b, it'll be y-intercept, right?
Mm-hmm.
That's correct. So we should be having that clear sense here that if a comma 0 is a point, then it is obviously an x-intercept. It is falling on x-axis somewhere. And 0 comma b is having x is 0, so it is a y-intercept, so it'll be falling on like y-axis somewhere. You got it?
Yeah.
Okay. Now after that,
If a plus b equals 0 and a doesn't equal b, which of the following is true about the slope on the graph of f?
can you make it simpler? Can you plug in the value of a is something and b is something so that a plus b is 0?
A can be 5 and b is -5.
Correct. So when you graph it, like when you graph this point is a comma 0, won't that be 5 comma 0?
Yes.
1 2 3 4 5 5 comma 0. So can I say this point is here?
Mm-hmm.
And what about 0 comma b?
It'll be down 5.
Down 5, right? 1 2 3 4 5 -5 0 comma -5. So it'll be 0 comma -5 here on the bottom. Can we join the line?
Yes.
So what do you say about the slope of this line?
It's positive.
Always, when you move from left to right and you're going up the mountain, it is positive.
Okay.
And when you go down the mountain, it's negative
Okay.
from left to right. So which option?
A.
Correct. Even if you plug in like A as -5 and B as 5, still you'll be getting the slope as positive.
Okay.
So making the things easier gives you the answer.
Okay, I got 26.
Okay, so we're having some graph here, and it's like, some lines, and they're telling you the complete graph of the function f is shown in the xy plane, which of the following are equal to 1. So f of -4. What do you mean by f of -4?
When it's f y, when x is f, or is, I mean -4 is y.
When x is -4, what is the value of the y? That's what it means. When x
Okay.
is -4, what is the value of y? So when x is -4, like -1, -2, -3, -4, what's the value of y?
1.
So this is 1. What about f of 3/2 or 1.5?
Uh, it's 1.
Yes, it is, because you're having 1.5 here in the middle of 1 and 2. So if you check it out here, so this is 1. And what about f of 3?
F is 3. 1.
1, correct. Which option?
No. D.
Right, 1, 2, and 3, all are 1.
But how do you figure out, like, if when it's a fraction, how do you figure out, like, if it's telling you the slope or like a decimal?
What, like, because they're telling you it's a function, they're not telling you it's a slope. They're saying it's f, what's the value of f of 3/2 or f of 1.5? So f of 1.5 means when x is 1.5, what should be the value of y?
Okay.
So what do you mean? Are you saying about the line here, which is here?
Oh no, I was just trying to like figure out like
Mhm.
when to like if you should put it into a decimal form like for or you would use it like as a slope.
You don't have to use it as a slope. Where are you using it as a slope? You're not using it as a slope anywhere. You're using it as a point, the x point,
Yeah.
the
Mm-hmm.
x values and the y values. They're telling you what is the value of y when x is -4. They're telling you what's the value of y when x is 3.5, 3/2, that's 1.5. And they're telling you what's the value of the y when x is 3. So you have to check out from the function, what are the values of y's when x's are -4, 1.5, and 3. For -4, the value of y is 1. For 1.5, the value of y is 1. For 3, the value of y is 1.
Okay.
So you don't have any inverse slope.
Okay.
Whenever the number is written in a fraction, that doesn't mean it's a slope.
Okay.
Slope can be, when you're having m equals something. So there you can say that, yeah, that's a slope. So option D is the right answer for this question. What's the next one?
27.
So there's some graph which is giving you the temperature and the time of the insulated and the non-insulated things. So insulated and non-insulated is starting at 60 degree, and then the non-insulated is going down faster, you see?
Mm-hmm.
And the insulated is going down slower in time. With time, when time increases, the temperature decreases for both of them, but for the non-insulated, it's going faster, isn't it?
Yes.
Okay, now let's read the question. Two samples
Mm.
of water of equal mass are heated to 60 degrees Celsius. So there are two samples of water, they're heated at 60, so that's what they are starting at 60. One sample is poured into an insulated container, okay, and another one is poured into a non-insulated container. The samples are then left for 70 minutes. So that's why you're having at the end 70. So they are left for 70 minutes to cool in a room having a temperature 25 degrees Celsius. All right. The graph above shows the temperature of each sample at 10-minute interval. Okay, we have understood that for the non-insulated, it's faster, for the insulated, slower. And they're telling you, after this, they're telling you, which of the following statements correctly compares the average rates at which the temperatures of the two samples change? So option A, in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated sample is greater than the non-insulated sample. So where you're having the rate of change greater, is it in the insulated or non-insulated?
Um, Insulated?
What do you mean the rate of change like?
Um,
Isn't that, how faster it's going up or down, isn't it?
oh, okay.
So which one is going faster?
The non-insulated.
The non-insulated, right?
Yes.
So the first option is the magnitude of rate of change of the temperature of the insulated is greater. Is that true? Is the
Mm,
insulated having the greater rate of change?
no.
So that's false. What about B?
In every 10-minute interval, the magnitude of the rate of change of temperature of the non-insulated sample is greater than the insulated sample. And that's true.
That's true. Correct. We are done. Let's still see option C.
In the intervals from 0 to 10 minutes and from 10 to 20 minutes, the rate of change temperatures of the insulated sample are of greater magnitude,
Or
whereas in the
you can check it out. Are you having greater magnitude from 0 to 10 and 10, 20 for the insulated sample?
no,
No. So why to read the next portion? D.
in the intervals from 0 to 10 minutes and from 10 to 20 minutes, the rate of change of temperature of the non-insulated sample are of greater magnitude,
Mm-hmm.
whereas in the intervals from 40 to 50 minutes and from 50 to 60 minutes, the rate of change of temperature of the insulated sample are of greater magnitude.
40 to 50 and 50 to 60. Um, well, this seems to be correct. You see here.
Mm,
So the rate of change for the non-insulated is greater from 0 to 10. Non-insulated, you're having greater from 0 to 10 and 10 and
uh-huh.
20. Check it out.
Yeah.
And when you think of non-insulated, well, it's obviously greater from 0 to 10 and 20 and 20 than the insulated, because the line is more steeper than the insulated. But when you go to the lower, like more time, 40 to 50 and 50 to 60, where the rate of change is greater.
Um, in the in the insulated one.
Obviously, yes. So from 40 to 50, the insulated is having more steeper line than the non-insulated. And from 50 to 60, again, the insulated is having more steeper line than the non-insulated. So option D and B are having a, you know, option D